This is the last section in this chapter about rationals. We've done everything else there is to do. We've simplified, we've multiplied, we divided, we added, we subtracted, we solved equations. We solved equations that were from word problems. The only thing left to do now is to graph them. And I actually am going to divide this up into two parts. So this will be part one. But we know what a rational function is at this point. It just means that it's a fraction, just algebra stuff in a fraction, for lack of a better way of saying it. And the most basic rational function that we could possibly be dealing with would be one like this, 1 over x. This is actually called the reciprocal function. And I went ahead and, made a table for you. And I just chose these x values at random. You could actually pick whatever x values you wanted, but just to save you some time, I did it for you. We took these x values, we substituted them in for x in our function, and came up with those y values, and we're going to use that to come up with a graph. All right, so when x is -4, y is -1/4, so that would be 1, 2, 3, 4 this way. And then I'm just going to kind of approximate -1/4. That would barely be below the x-axis, somewhere in there. When x is -1, y is -1. So now I am right there. And when x is -1/2, y is -2. So when x is -1/2, and I'm just eyeballing it, y is -2. So right there. And then when x is 0, if you substitute 0 into this function, you get 1 over 0, which is undefined. That's not a point that we can plot. We'll talk about what that means later, but for right now, it doesn't mean anything as far as me plotting points. So then I keep moving, and you notice that these are all just kind of the opposite of these. When I'm at +1/2, the y coordinate is +2, +1 is +1, and +4 is 1/4. So 1, 2, 3, 4, 1/4. And you could plot more points if you still didn't really understand what was going on, or you could just kind of do them in your head. You see how as these x coordinates get bigger and bigger and bigger and bigger, the y coordinate just becomes 1 over that number. So that y coordinate is just getting smaller and smaller and smaller. So if I had like x is 10, for instance, y would be 1/10. So in other words, the further out you go that way, the smaller that y coordinate is, so the closer we're getting to the x-axis. I can take it all the way out to like 1,000, and that y coordinate would be 1 over 1,000. Also, as I'm getting closer to 0, so like, when my x coordinate was 1/2, my y coordinate was 2. But imagine if my x coordinate was 1/4, then my y coordinate would have been 4. If my x coordinate was 1/10, which would just be barely right beside the origin there, if x was 1/10, then the y coordinate would be 10. It would be way up there. And so the result of that is you get this shape. Your graph is shaped like this. It's sort of steep right there, and then it kind of flattens out right there and goes that way. And it gets closer and closer and closer and closer to the y-axis right there, and it gets closer and closer and closer and closer to the x-axis right there forever, but it never actually intersects it. And we can show that with our table. You're never going to put an x coordinate in here and get 0 for a y coordinate. It's not possible. All right, and you're never going to put some y coordinate in here and get 0 for an x coordinate. We just showed that right there, because when x was 0, it was undefined. So that's what you get up there for those positive values. You get the same thing down here, same explanation and everything. It would just be like that. And so that is a graph of this basic reciprocal function, which is a basic rational function. All right, now we've talked about these words in the past, but they really get hit hard in this section. This is when you really have to understand asymptotes and all of that stuff. And remember, an asymptote is just it's a line, but it's not a line that's part of the graph. It's just a line that our curve gets closer and closer and closer to, but it never intersects it. And we actually, just in our discussion of the table here and our drawing of the graph, we've really already kind of established where these are. We just got to write them down now. So my horizontal asymptote, when they say what is the horizontal asymptote, they want to know what is the equation of the horizontal line that these points are approaching, but they never actually get there. Well, that horizontal line, you can see it on the graph. It's right there. And so that horizontal asymptote is y equals 0. You remember horizontal equations or horizontal lines start off with y equals, and then it's whatever it equals. Well, the vertical asymptote, kind of the same thing. That's the vertical line that these points are approaching but never actually intersect. And we can see that on the graph that vertical asymptote is right there. It's sort of, it's almost like a barrier keeping that curve from crossing there and from down there. And so that vertical asymptote is just x equals 0, because vertical lines, the equation of vertical lines start off with x equals. All right, key points. Well, anything could be a key point. Like key points just mean we're going to use these when we start transforming this thing around, but we're going to keep it simple. I'm just going to use the easiest points that I have up here on my table, which would be -1, -1, which is that one right there, and 1, 1, which is that one right there. That way I'm not messing with any fractions. And the only reason we even record those is because, just like with every other type of graph we've done, we're going to start shifting it around. And when we start shifting it, the things that we're going to shift are going to be the asymptotes and those key points. That'll make it kind of easy. All right, domain and range. Well, remember, domain means how far to the left does it go, how far to the right does it go, and does it skip anything in between? Well, you can see that this thing goes to the left forever. We can see that it goes to the right forever. So its domain starts with -infinity and its domain ends at +infinity, but we need to decide whether or not there's anything missing in between there. And there is. We've already said that we have a vertical asymptote at x equals 0, which means that there can't be any points that have an x coordinate of 0. So the x coordinate 0 cannot be a part of the domain. And so you remember the way we say that is we do a parentheses, -infinity to 0, and it's a parentheses, not a bracket. It's a soft parentheses because 0 is not really included. It gets all the way to like -0.000000001, as many zeros as you can imagine with a 1, and then it gets even closer to that. But it never actually makes it to 0, so we put a parentheses on the 0. That's our way of indicating that. Then we put our little union symbol, and then we have another interval because it picks up right on the other side of 0, and then it goes to the right forever. So it's 0 to infinity. And then the range does the exact same thing. This range, remember, range means how low does it go, how high does it go? This thing goes down forever, it goes up forever. So it starts at -infinity, it goes all the way to +infinity, but is it missing anything in between? And it is. We said that there was a horizontal asymptote at y equals 0. That means there is no point on this graph that has a y coordinate of 0. Therefore, our range is -infinity to 0, 0 to infinity. All right, increasing and decreasing. Well, this is going to look a little weird, but not really. It's not really terribly difficult. When you're doing increasing, decreasing, you're reading it from left to right, and what you're doing is you're saying the x coordinates where this thing is increasing, and then the x coordinates where this thing is decreasing. Well, as I'm coming in from left to right, this thing is on its way down. It's on its way down, on its way down, on its way down, and then it just keeps going down. And then even if you were to jump over to this side, it's still on its way down, on its way down. So this thing's entire domain is decreasing. So if that's the case, if it's always decreasing, then, we'll just say decreasing, and then our response to when it's decreasing will just be the same as our domain, because it's always decreasing. And it's never increasing. Always decreasing, never increasing. And that's it. Okay, so what you have to do with these is you have to take that that basic rational function, which we call that our parent function. That's the parent function for these. So we're going to take that basic reciprocal function and then just do the same thing that we've been doing all semester with every kind of function that we've learned. So you can stretch these out, you can shift them, you can reflect them, and all the rules that we've learned, all the rules that we've been applying all year, they are true for this as well. So in a problem like this, for instance, I got 1 over x plus 2. Well, we learned a long time ago that when you add or subtract a number directly to the x, remember that's different than adding or subtracting 1 out on the end. You add or subtract a number directly to the x, that causes it to shift sideways. And it's actually kind of backwards from the way you think it probably would be. So x plus 2 actually makes it shift to the left too. So remember the one we did just a minute ago, the key points. This is the only reason that we even recorded those key points. One of the key points was at 1, 1, and the other one was at -1, -1. Well, if I take that point that was at 1, 1, and I shift it to the left 2 units, well, now it's right there. And if I take that point that was at -1, -1, and I shift it to the left 2 units, well, now it's right there. And the other thing that gets shifted are the asymptotes, potentially. So, take this horizontal asymptote. On the parent function, there was a horizontal asymptote at y equals 0. Well, if you shift something horizontal, if you shift a horizontal line horizontally, well, then it doesn't change. So this horizontal asymptote is still y equals 0. The only way you're going to affect the horizontal asymptote is to, do something vertically. The vertical asymptote, however, used to be at x equals 0. It used to be right here. Well, it got shifted to the left 2 units also, and you can tell from where your points are, you can kind of see where it's going to be. But now that vertical asymptote is right there. So I have a vertical asymptote at x equals -2. And then you could put more points on here if you want to. Actually, if you get that much done, that's good enough for me right there. And we're just going to draw in a basic reciprocal function that got shifted to the left 2 units. And we're done with the graph. And that's a good enough answer. All right. Well, x-intercept, y-intercept. We didn't answer these for that first one, but these are easy to do. First off, the x-intercept. Well, if I have a horizontal asymptote at y equals 0, we've already kind of established, at least on this one, that there are no points that have a y coordinate of 0. Well, if there are no points that have a y coordinate of 0, then there is no x-intercept. And you can even look at it on the graph. You can see that it never crosses the x-axis. So this would just be none. The y-intercept, well, you could look over there and just eyeball it, but I don't really want you to do that. I want you to calculate some stuff. Remember, if we want a y-intercept, we just let x be 0 in the original equation. And if I did that, it would be y equals 1 over 0 plus 2, which is 1/2. So my y-intercept is the point 0, 1/2, which you can kind of see on the graph. That sort of makes sense. All right, the domain. Well, remember on the last one, the domain started at -infinity, went to 0, then it picked up at 0, went to infinity. Well, that same thing's going to happen, except for that x-coordinate this time where it stops, or that's not included, is not 0 anymore, it's -2. So my domain is actually -infinity to -2, 2 to infinity. My range, since we didn't move that horizontal asymptote, my range stayed the same, -infinity to 0, 0 to infinity. And then just like on the last problem, this thing is always decreasing. If you're moving from left to right at any place on this curve, you're always on your way down. Moving left to right, you're always decreasing. And so this thing is decreasing. I'm just going to circle decreasing because it's never increasing. This thing is decreasing on its entire domain, which would be -infinity to -2, 2 to infinity. Easy. This is D in your notes, if you printed off the handout, you didn't really need to. The only thing that would help there is that you'd already have the little graph for you wouldn't have to draw it yourself. But I'm not doing all of them because they're kind of the same thing over and over. But I did want to do this one. We did one that had a horizontal shift. This one's got some different things going on, so I wanted to do it also. Again, all the rules that we ever learned about transformations, those all still apply here. So this negative that's out in front, that is going to cause a reflection over the x-axis. Reflection over x. And then that -2, remember we said just a minute ago that if you add or subtract a number out on the end like that, that causes it to shift vertically. So this thing's going to go down 2. So it's going to reflect over x, then it's going to go down 2. All right, well, remember the key points, the 1, 1, and the -1, -1. So this point that used to be at 1, 1, if I reflect it over the x-axis, well, then it would jump to right there. And then if from there I went down 2, then that would be down 2. It would actually end up right there. So let me erase these little extra marks there. That's the point, though, that used to be at 1, 1. All right, the other key point was -1, -1, which used to be right there, or well, that is -1, -1. If I reflect it over the x-axis, it would actually jump up to right there. And then I shift it down 2 units, it's going to come down 2 units and end up right there. It actually ended up where it started. You reflected it and then shifted it down 2, it just landed where it started. All right. Well, I got to worry about these asymptotes. And again, though, I think probably the easiest thing for you is just look at those key points, because those key points will kind of give away where the asymptotes are. And, it looks like if I were to draw these asymptotes in just sort of based on where those points are, it looks like that vertical one would go down like that, and that horizontal one would go down like that, which makes sense because, we shifted the graph down 2, so that would mean that horizontal asymptote went down 2, so it is now at y equals -2. Whereas if you take a vertical asymptote, you reflect it over the x-axis, that's not going to do anything. That's still going to be the same line. And then if you shift it down 2, that's not going to do anything. It's still going to be the same line. So I have a vertical asymptote stayed at x equals 0. All right, I'm going to go ahead and draw this in. This one's kind of backwards from the other ones because it got reflected. But oops, I missed my point there. It would basically look like that. And so I need this x-intercept and this y-intercept. Well, just at a quick glance, because I had that vertical asymptote at x equals 0, I know there's not going to be a y-intercept, so we don't need to worry about that. But I can see on the graph, and it's not a very good drawing, but I can see where this thing crosses the x-axis. So if I want to know what the x-intercept is, I need to let y equal 0. So that's what I'm going to do. I'm going to say, all right, 0 equals -1 over x minus 2. I'm just going to do some algebra here. I'm going to add 2 to both sides. I'm going to multiply both sides by x. And then I'm going to divide by 2. And so that point right there, you can't really tell from my drawing, but that x-intercept right there was -1/2, which means right here, this is -1/2, 0. All right, since your vertical asymptote didn't move, that means your domain is going to be the same as it was for the parent function, for the original reciprocal function. The range will change a little bit though, because that horizontal asymptote came down. So instead of going from -infinity to 0, it's actually going to go from -infinity to -2. And then pick up at -2 on the other side of -2 and go to infinity. Last thing, the increasing, decreasing. Well, this time, as you go from left to right, this curve is always on its way up, regardless of what section of the curve you're on. You're always increasing. So this thing is always increasing, never decreasing. And if it's always increasing, then the answer to this increasing interval is just whatever the domain was. So this thing is increasing from negative infinity to 0 and from 0 to infinity. And that's all.